Problem number 2492. Minimum score of a path between two cities. You are given a positive integer n, representing n cities numbered from 1 to n. You are also given a 2D array roads, where roads I equals ai bi distance I, indicating that there is a bidirectional road between cities ai and bi with the distance equal to distance I. The cities graph is not necessarily connected. The score of a path between two cities is defined as the minimum distance of a road in this path. Return the minimum possible score of a path between cities 1 and n. A path is a sequence of roads between two cities. It is allowed for a path to contain It is allowed for a path to contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. The test cases are generated such that there is at least one path between 1 and n. Okay, so basically it's, you will start it from 1 and then you have to calculate the minimum distance, the minimum distance to the last node, to the last city, and it's a bidirectional road. Okay, so the first question that I want to ask is, so the distance will, like the range of the distance, what is the range of the distance and what is the range of n, and also is A and B going to be the same, and like in the roads, is there same A and B in the roads list with different scores? Okay, let's see. There are no repeated edges. Okay, and A must not equal to B, and distance is at least 1. So it's positive integers, and n is at least 2. Okay. And road length is at least 1 as well. Wait, but so is there like road length is 1 and n is 2? Okay. Road length is at least 1. Okay, so I think it's like yeah, like we can so we will start from node 1 and then yeah, and then we will move to the connected city, and yeah, we'll make the problem become becoming the next connected node, like the minimum distance from the next connected node to n. Yeah, so it's like a recursion problem. So it's like so yeah, the problem will shrink. So starting from node 1, the problem is find minimum distance from node 1 to n. Then we will moving to the nodes connected with node 1, the problem shrinks to find min distance from node from the connected node to n. Okay, so I think we can write a recursion and we will use DFS. So DFS I will be the minimum distance from node I to n. So we can have like this minimum DFS, I'll say connected node J plus distance, from distance I, maybe like this, distance I, J, and we will have many connected nodes. So yeah, that's all. So the first thing that we want to do is to create an adjacency list. So we will have nodes equals to a default tick, and for roads in for R in roads, A B distance equals R, and we will have nodes A append B. Oh, we also should have the distance. Let me think. Yeah, we should have a better data structure to store the distance, not just connected. So we change like list of tuples, so we will have append b tuple, b distance, and nodes. Yeah, since it is a bidirectional road, so we'll have b as well and append a distance. So we'll have data structure like C1, maybe it's 2 and it's 9, and we'll have 4 and its distance is 7. Yeah, and 2 will be 3 and 6, then 4 and 5. Yeah, like this. Okay, after the adjacency list, we will start our DFS. And yeah, we should create the visited array so that we will not enter infinite loop. So it's false in the default, and we have and nodes. So when we are at the node I, we will set, I think we will have n plus 1 since let me think. Yeah, we will start it from 1. Maybe we'll have a set, will be easier. So visited at node I, and then we will start our minimum distance. Yeah, minimum distance calculation. So for node in nodes I, the connected nodes, yeah, the connected node, if the node is not visited, then we will visit it. Yeah, we will calculate its distance, and then its distance to node n, and then plus ourselves, plus the distance I to the node. So we will have DFS node plus distance. Wait. Yeah, what knows it? We will have, yeah, it's a tuple, so we have to unpack. So it's I'll say value. So it's node and distance equals value, yeah, plus distance. Yeah, we have to that sum up. No, we have to have the min. So we will say min distance, and it will be default. Default, I think we will give it an n. Okay, and then min, this will be min this. Yeah, and only if okay, I think it's not. Yeah, since we need to find the path to n, I don't think we can do the minimum for now. I think we need to find all the paths to n, and then we should sum up the path to n, sum up the distance to n, and then find the minimum. If the definition of DFSI is the min distance from node I to n, then this is okay, so this is correct, but if we have to consider the situation that that this node cannot reach the end node. Let me think. So, or we have to do it outside. I mean this, and what equal to inf at first, and if I equals n, then we will have some score equals 0. So return, not return. We will return, and then but we have min, we will have min this. We will calculate the score now. And we'll remove this. So score is we'll have like this. And we should remove it after the recursion. So score minus distance. And return then this. We will run the DFS first. So let's start with 1. Yeah. Oh. So I should have non-local score. I think I will have it here. Oh, okay, so that's added here. Oh, is that because I did not add the distance of this? Oh, already added. Yeah, maybe dry run first. So for the first case, we have for 3, I'll have 6, 5, and oh no, it's 2, 6, only 2, so it's 2, 6, and then for 4, I'll have 2, 5, 2, 5, and 1, 7. Or maybe we don't need the visited set. Like if we met, yeah, maybe if we met and then it's done. Okay, no, it will be an infinite for loop. But yeah, like you can go from 1 to 4, 1, 1, 4. Wait, the path from city 1 to 4 with the minimum score is 1 to 4. Why is not 1 to 7? That's 7. Let's check the problem again. The score of a path between two cities is defined as the minimum distance of a road in this path. Return the minimum possible score. A path is a sequence of roads between two cities. It is allowed for a path to contain the same road multiple times, and you can visit task it. Oh, it says the score of the path is defined as the minimum distance of a road in this path. Okay, so 1 to 4 is 7, 1 to 4 is 9 and 5 with the minimum. So it's not sum. It is yeah, it's like a minimum. Like this. So it will be let me think. So when you're at 1, you can for loop these two nodes and check its, we will check its road if it can meet n, and then so we cannot use this. We will use yeah, I think it will be the minimum. like you will have minimum between score, minimum of DFS node and distance. That is your score. And among score, you should find a minimum as well. Yeah, but if this, I'm not sure if this can reach the last node, like or should I yeah, maybe I should add score into a parameter so it's will be like this. And so score now is inf, and if, okay, so for value in nodes I, node distance is not visited, we will try to find the distance like I don't know what to put here for okay, its score will be distance. Okay, I'm kind of confused. Let's check the solution. Oh, it is even okay, I found that this problem is not asking for like the sum of the distance or like the minimum distance. It's asking like example 2, the path from city 1 to 4 is the score is 2. So it's because you can, like it says you can go to the same road and then move back. So basically it's only asking the minimum distance between it's asking the minimum edge, like the minimum distance in the graph. So we'll only need to find. So no score is needed. We'll start from 1 and then we don't need this since we don't have to check if we can reach node n, since it says it will be at least one path between 1 and n. So let's just find the minimum edge. Okay, so not n visited, let's have we'll have this remove the score. We will have we will basically check every distance that we can reach. So wait, did I miss something? Like I should put it here. When we get the distance, we cannot. Okay, so moving this line to here is because if I do it here, then basically only the node that is not visited will check the current distance, but the current distance should be checked every time it is reached. So it should be here. And let's do submit again.